Given y equals x bracket 2x plus 1 to the power of 4, show that dy over dx equals 2x plus 1 to the power of n brackets ax plus b, where n, a and b are constants to be found. So for this question, we need to use product rule, and we've got it up here, which is dy over dx equals u multiplied by dv over dx plus v du over dx. And first what we need to do is we need to set x as u and v as 2x plus 1 to the power of 4. So these are two separate, u and v. And then we need to find out what each of these are when they're differentiated. So x differentiated is 1. And for v, it's a little bit more complicated. We need to bring the 4 to the front, just as you would with normal differentiation, and then reduce the power. So you get 4 bracket 2x plus 1 to the power of 3. And then with the inside of this, we need to differentiate this, and then multiply it by this. So it's basically product rule and chain rule. This is mostly product rule, and this little bit is chain rule. So yeah, we need to differentiate this, which will just be cancel out the 1, 2. So we do 4 bracket 2x plus 1 cubed multiplied by 2, which gives 8 bracket 2x plus 1 cubed. Hopefully that wasn't too complicated. And then after that, we just need to sub these in back into this equation. So we have u multiplied by dv over dx, so this part here. And then we add v multiplied by du over dx, which is just 1. And then we add them, which gives us ax bracket 2x plus 1 cubed plus 2x plus 1 to the power of 4. And then obviously this isn't in this format that the question wants it to be in, so we need to take out a common factor of this. And from this equation we can see the common factor is 2x plus 1 cubed, as it can go into this and into this. So we do 2x plus 1 cubed on the outside of the brackets multiplied by this 8x plus 2x plus 1 to the power of 1. And that is... oh yeah, and then we add these to ax plus 2x plus 1, which gives 10x plus 1, and that is our answer. And as you can see, it fits the equation. N equals 3, a equals 10, and b equals 1. A curve has the equation x cubed plus 2xy plus 3y squared equals 47. Find dy over dx in terms of x and y. So it can get tricky here because obviously you're dealing with an x and a y. So for the first part, we can just differentiate this as normal in terms of x. So we're going to do 3x squared. And for this part, we're going to do 2, obviously get rid of the x, 2y plus 2x dy over dx, because we do this multiplied by dy over dx to get rid of the y. And then for this part, we bring the 2 in front, which gives 6y multiplied by dy over dx again, because we need to get rid of the y. And 47 is just nothing, so it equals 0. And then we need to bring the dy and dx terms to one side so that we can factor it out. So we do 3x squared plus 2y equals minus 2x minus 6y. And then we can just factorize this. And then to get dy over dx, which we're looking for on its own, we can do 3x squared plus 2y over minus 2x minus 6y. And this is the answer. Okay, so this follows on from the last question. The point P minus 2, 5 lies on the curve. Find the equation of the normal to the curve at P, giving your answer in the form ax plus by plus c equals 0, where a, b and c are integers to be found. So when it says equation of the normal, it means the perpendicular sort of gradient. So we need to find out the value of the gradient at minus 2 and 5, and we find the values of gradients using dy over dx. So we're going to bring this in from last time, this one that we figured out from dy over dx, and then we're going to sub in -2 where the x is, and 5 where the y is. And then doing this will give us -22/26, which can be simplified into -11/13. And this is our gradient for this line, but because it's normal, we need to find the gradient for this line because it's normal, which is a perpendicular one. So we need to find out the gradient of the normal. We do the negative reciprocal, which would be 13/11. This negative cancels out. And then to find out this equation, we use the equation y minus 5 equals 13/11 bracket x plus 2. And then we can expand this out. And then doing this, we multiply everything by 11, which will give 11y plus 13x plus 81. We do this just to get rid of the fractions here. And then we can just rearrange this to find it in the form of this equation. Find f to the second derivative. F of x equals x cubed plus 2x squared minus 8x plus 5. So first we need to find out this differentiated once. F of x equals 3x squared, bring that to the front, plus 4x minus 8 because this x cancels out. And then we do this again to this part to give us f of, this should be like that, to give us f to the second derivative. And that will be 6x plus 4. Part B. Solve f of the second derivative x equals 0. Hence, find the range of values for x for which f of x is concave. So to solve this equals 0, all we need to do is take this, again, made a bit of a mistake. We set this to 0 and just work it out in terms of, we need to solve it for x. So 6x plus 4 equals 0. And x equals -2/3. You can just work this out really simply by minusing 4 and dividing by 6 on both sides. And then for part B, hence, find the range of values for x for which f of x is concave. So when something is concave, it's when its second derivative is less than or equal to 0. So this essentially needs to be less than or equal to 0. So that is literally it. The function f is defined by f of x equals 2x minus 3 over x squared plus 4. Show that f of x, the first derivative, equals ax squared plus bx plus c over x squared plus 4 squared, where a, b and c are constants to be found. So when we need to differentiate a fraction, we use the quotient rule, which I'll use up here. And all we need to do is find what u and v are, and then differentiate them, and then put them back into this equation. So here, u will equal to x minus 3, and our v equals x squared plus 4. We find out our u differentiated, which is 2, as this cancels out, and this cancels out. And then our v differentiated is 2x on its own, this cancels out. And then we put that back into this equation. So the v is x squared plus 4, and the u differentiated is 2, so you multiply them, and then you minus it by u multiplied by v differentiated here, and then we do this over v squared, so this squared, and then we can just expand these out, and that gives us this, and then we can rearrange it a little bit more, which leaves us with this, which is minus 2x squared plus 6x plus 8 over x squared plus 4 squared. And we can literally leave it in this form, as this is what the question asks us. Hence, using algebra, find the values of x for which f is decreasing. You must show each step in your working. So using the top part, the numerator from earlier, from this question, obviously this isn't really relevant, we just need to use this. We can set this to 0, to find out when f is decreasing. And then we can factorise it out, so we can divide everything by -2. And then we can factorise from that point, which gives us -2 bracket x plus 1, x minus 4. That isn't relevant. And then we get the values of x as -1 and 4. And then to work out what sort of direction each of the like greater than, less than values are going in, we simply draw out our function. We know that this is going downwards and it meets at -1 and 4. This is really wonky and not exactly accurate, but using this we can sort of see from -1 and 4, the parts where it is decreasing, as in going down, is when it is less than -1, because you have like a -2 here, -3, and then it is greater than 4. So like you have 5, 6. So that's how you'd write it. You do x is less than -1, -2, -3 are all valid, and 5 and 6 are also valid, so it would be greater than 4. So these are your two inequalities. Sorry, this has been drawn on, but you get the gist. Okay. Given that y equals 3 sine theta over 2 sine theta plus 2 cos theta, show that dy over d theta equals a over 1 plus sine 2 theta. Again, we see a fraction, so we automatically use the quotient rule, which I just love adding in the corner quite a lot. But yeah, and then we need to obviously find the values for u and v, and then those differentiated. So our u is 3 sine theta, and our v is 2 sine theta plus 2 cos theta. And then when we differentiate u, this will just give us 3 cos theta. And when we differentiate v, it will give us 2 cos theta minus, because when cos differentiates into sine, it becomes a minus sine theta. And then all we need to do is just put these back into the equation. So we do this v from here multiplied by 3 cos theta, and then this minus here, 3 sine theta from here multiplied by this v differentiated. And then we can expand this into this. And then if you look at these parts of the equation, you see they actually cancel out. So you can simply just cancel these out, and then you're left with 6 cos squared theta plus, because a minus and a minus makes positive, 6 cos theta squared theta plus 6 sine squared theta over, and then v squared, so our v is here, 2 sine theta plus 2 cos theta squared. And then we can just expand this out, and it gives us 4 sine squared theta plus 8 sine theta cos theta plus 4 cos squared theta. And then we can take the 4 out because it's got a common factor of 4, and then we can rewrite this as 4 bracket sine squared theta plus cos squared theta equals 2 sine theta cos theta. And what you'll realise actually is these two can both form your identity and double angle formulae. So we know sine squared theta plus cos squared theta equals 1, and 2 sine theta cos theta equals sine 2 theta. And then we're using this equation, we can just put these back in, so we can put a 1 here and the sine 2 theta here, and it becomes 4 bracket 1 plus sine 2 theta, sorry, every x should be theta. And if we expand that, which gives 4 plus 4 sine 2x. And then this can change into 4 plus 4 sine 2x to make it neater, and also to fit this form. And then this still doesn't fit our value of a, so we can factorise the 6 out. And oh yeah, as we know, obviously cos squared theta plus sine squared theta is 1 from earlier, so 6 times 1 is 6, and then from here we can take this out and make it a 6. And this is nearly our final answer, but we want it in 1 plus sine 2 theta, so we need to take out the 4, so we divide by 4 on the numerator and denominator on both sides, and that will give you 3 over 2 over 1 plus sine 2 theta. Given that y equals ln x squared plus 1 over x, find dy over dx. So again, we're going to use the quotient rule and we're going to get our u and our v. I'm doing v first because it's a bit simpler, which is v equals x, and then u equals ln x squared plus 1. And then when we differentiate v, we just get 1. And we differentiate u, essentially what we need to do is, when you differentiate ln bracket something in the brackets, is always the this part differentiated over this part. So to explain it better, if you differentiate this, it gives you 2x, and then you do it all over x squared plus 1, and that is it. So this will equal our u differentiated, and we put this back into this part of the equation, as you can see here, and then we can expand these out, so it'll be 2x squared over x squared plus 1, and then minus, you can get rid of the 1, ln x squared plus 1. And then, not to forget, we need to do this over v squared. So we're going to do all of this over x squared. And then obviously this is quite a lot to deal with at once. So we're going to break this down to be more manageable. So we'll do this part first, which is 2x squared over x squared plus 1. To divide this by x squared, we just need to multiply it by 1 over x squared. And as you'll see, these terms will cancel out. So you're left with 2 over x squared plus 1. And then for this part, we need to do ln x squared plus 1 divided by x squared. And we can just rewrite this as 1 over x squared multiplied by ln x squared plus 1. And dy over dx equals, and then we just need to put these back together, 2 over x squared plus 1 minus, not to forget the minus, 1 over x squared ln x squared plus 1. Part 2. Given that x equals tan y, show that dy over dx equals 1 over x squared. So we're going to do this separately, so we can differentiate tan y first. And as you should know, tan y differentiated gives x squared y. But obviously, because it's in terms of x and y, you do sec squared y multiplied by dy over dx, like we did in previous questions. And then we differentiate the x, which gives us 1. And then we can set these to equal each other. So 1 equals sec squared y times dy over dx, like we've done here. And then to get dy over dx on its own, again, we just divide each side by sec squared y. So dy over dx gives 1 over sec squared y, and as we know, sec squared y is equal to 1 plus tan squared y, so we can rewrite this as 1 over 1 plus tan squared y. And then we know from this part that tan y equals x, so we can rewrite this as 1 plus x squared, which will perfectly match this. And there you have it, that's your answer.